Introducing XLTA, the next generation in wound care. This hydrocapillary flow demonstration shows how XLTA sets a new standard as a super-absorbent, non-adherent, sophisticated exudate management system. The clear bottle contains water representing wound exudate. The other contains food dye, simulating bacteria and inflammatory byproducts present in the exudate. These fluids allow us to visualize how XLTA functions in a real-world wound environment. Hydrocapillary fluid transfer. A pool of clear fluid is poured to simulate a moist wound bed. Dye is added to the pool to simulate bacteria-enriched exudate produced by the wound, containing bioburden, bacteria, cytokines, enzymes, and debris. A pre-cut piece of XLTA is applied to the fluid mixture, and the hydrocapillary flow can immediately be seen in action. When dry fibers are introduced to the saturated dressing, such as a fresh piece of XLTA, the layer-to-layer fluid transfer of the hydrocapillary mechanism is activated. Only a small corner of fibers needs to be in contact for the moisture-intelligent dressing to continuously wick fluid. Continuous hydrocapillary flow. Dye is added directly onto the non-adherent outer layer of the XLTA dressing. It is instantly absorbed undeterred by the outer layer. Clear fluid is added from one side, and the fluid dispersion technology can be seen as the fluid mixture moves towards the end of the dressing where dry fibers remain that drive the wicking action. The bacteria-simulating dye is visibly carried along with it, showing how XLTA absorbs and distributes fluid. A fresh piece of XLTA is placed adjacent to the saturated dressing, and more fluid is added to the original dressing, simulating exudate produced by a wound. The layer-to-layer fluid transfer mechanism can be seen as the dye is moved from one layer to the next. More dye is added to the primary layer, simulating more bacteria-enriched exudate being produced by the wound. Clear fluid is added to the saturated dressing. As the wound would exude more fluid, the dressing carries away the excess fluid with its unique wicking technology. Note that XLTA's function is not depleted after the first use. Interrupted dispersion. XLTA's ability to wick fluid around obstructions and irregular wound shapes or dressing arrangements. As we introduce fluid to the wound bed, you'll notice how XLTA's hydrocapillary mechanism redirects the exudate towards the dry fibers, pulling it around the missing section instead of pooling at the site of disruption. This response is driven by XLTA's omnidirectional dispersion, the ability to move fluid not only horizontally and vertically, but around voids and anatomical irregularities. Where traditional dressings fail, leaving moisture trapped or stagnant near hard-to-dress areas, XLTA responds dynamically. XLTA does not require full or direct contact with every wound surface to remain effective. Instead, its proprietary blend of natural fibers coordinates fluid transfer across all connected areas. Even with disrupted geometry, the dressing retains fluid, sequesters bacteria, and manages moisture, safeguarding the wound environment without disrupting the mechanism of action. This performance makes XLTA ideal for challenging wounds, such as undermining, tunneling, or partial exposure sites, where coverage is incomplete or inconsistent. XLTA maintains its function, absorbing, dispersing, and protecting. Vertical lift. This demonstration shows how XLTA absorbs fluid not only horizontally, but also vertically against gravity. Notice that the non-adherent layer does not impede or delay rate of absorption. The fluid is rapidly absorbed and dispersed unobstructed by the non-stick interface. A single pre-cut piece of XLTA is then placed upright, standing vertically on top of the flat dressing. As additional fluid is added to the primary layer, XLTA's hydrocapillary action activates, carrying the exudate and dye upward into the vertical piece via its natural mechanical vacuum. This clearly demonstrates XLTA's ability to wick fluid vertically against gravity, ensuring continuous absorption, even in layered or irregular applications. Vertical layering. This demonstration shows XLTA's omnidirectional dispersion by carrying fluid vertically against gravity throughout multiple stacked layers. XLTA is a high-performance, super-absorbent dressing sandwiched between two non-adherent layers. No side is the wrong side when placing the dressing. Multiple layers are stacked atop the primary dressing. If exudate exceeds expectations, pooling can lead to maceration or overgranulation, which is why we recommend using at least 2 layers when possible. The top layer draws fluid upward from the saturated layer below, expanding capacity while maintaining a balanced moisture environment. This also enables XLTA to transfer bacteria and liquefied debris upward, reducing bioburden across multiple layers and away from the wound bed safely locked into the XLTA fiber matrix. As exudate is secreted, the fluid moves through to the upper dressings without pressure or compression. This capability is ideal for hard-to-dress wounds, such as venous leg ulcers, where it is ideal for fluid to be wicked away from delicate or eroded wound beds. XLTA's hydrocapillary flow ensures constant fluid movement, omnidirectional dispersion, and continuous bacteria sequestration, all without chemicals or medication. Effective hydrocapillary exudate management, moisture regulation, and bioburden relief, assisting autolytic debridement and optimal wound bed preparation. Electrostatic charge. The XLTA healing triad consists of hydrocapillary flow and electrostatic charge as the primary drivers that create the wound environment from which proteolytic enzyme balance emerges as a secondary effect. Together, this unified system activates moisture intelligence in action, resulting in exudate management, autolytic debridement, and wound bed preparation for easy progression of wound healing phases by catalyzing and supporting the body's endogenous healing processes. XLTA's proprietary blend of predominantly natural, unmedicated, and chemical-free fibers inherently hold a positive electrostatic charge. Most bacteria are negatively charged. This allows for a targeted electrostatic attraction of bacteria and topical deeper tissue engagement, where bacteria, cytokines, and enzymes are electrostatically attracted from beneath the wound bed. As the wound exudes, XLTA rapidly wicks it into the dressing. Bacteria, cytokines, and enzymes are electrostatically adhered to the XLTA fibers, creating a double vacuum effect of hydrocapillary superabsorption and ionic sequestration. This prevents further proliferation and contamination, restoring balance to the wound environment. The dye in this demonstration shows how fluid is pulled upward, diluting the bioburden through hydrocapillary action. It's easy to see how regular dressing changes every 1 to 3 days maintain this cleansing cycle and reduce bioburden, giving the wound bed a stable environment to heal. Longer wear time can be accomplished by multiple layering and carefully considered securing methods. The new hydrocapillary standard in wound care, powered by XLTA technology,